Hey guys, I am Nihit, and in this video we will going to discuss about Node.js server architecture. We will see how Node.js under the hood process the request in the server and how server-side processing occurs in Node.js. Let me set the context for this video. First, we will see some components of Node.js architecture. We will see what are blocking operations and non-blocking operations. We will see some advantages and disadvantages of this architecture. And last thing, we will create an HTTP server using Node.js. So this is Node.js server architecture. Let's let a client. Let's name it client 1, and there is a Node.js server. There's a Node.js server running on, let's say, port 9000. Client 1 requested the server with some kind of request. It can be a blocking request, can be a non-blocking request, or after the processing has done, the Node.js server returns the response to the user. Mainly, we guys see this. Let's see how Node.js server processes this request body under the hood. In this server, there are two things. One is event loop and one is event queue and the other one is event loop. Let's name it event loop and let's name it event queue. Event queue. In the event queue, all the incoming requests from the clients get stored. And it follows the FIFO order first in first out because it's a queue data structure, and this event queue sends the request to the event loop in the FIFO order. Okay, so let's say, and this event loop processes this request body depending upon the nature of this request. If the request is a blocking request, here blocking request means, or blocking operation means a synchronous request, or non-blocking request or operation mean an asynchronous request. Okay, so request can be of two types, blocking and non-blocking. If this is a blocking operation, then the event loop executes directly. The event loop executes directly in the call stack, or the main thread. Okay, when it's a blocking operation, okay. And if it is a non-blocking operation, let's say it is a non-blocking operation, then the event loop goes to a thread pool. Let's name it thread pool. Here the threads are present. Let's say there are total number of 4 threads. Let's name them 1, 2, 3 and 4. The event loop goes to the thread pool and see if there are any threads, or you can call them workers. If any workers are available, then the event loop assigns the non-blocking operation to an worker or an thread such to complete or process this request. After the processing occurred, or after the processing gets completed, the event loop the thread goes into the event queue, and then event loop collects the request, or the processed request, or you can say response or result from the event queue, and collect that response or result from that thread and return that response or result to the client or the user. Why non-blocking operation goes to the thread pool? Because a non-blocking operation needs to do can query a database, can query a DB, it can fetch API fetching, or need some computation. To do all these tasks, the event loop assign a worker to process this operation. And to process this operation, and after that the callback is queued in the event loop in poll phase, and it will only execute after the current synchronous code completed or after the blocking operations get completed. Because uh, here comes a disadvantage of this Node.js server architecture. Because it is a single threaded architecture, then it can becomes a bottleneck for CPU intensive task. Let's say it's limited to one thread. Like when there comes a blocking operation, there are multiple users, they send the request. If there will be no if all the workers are busy in in processing any other request, then it's then user have to wait for a lot of time to the previous request gets processed. After that, his or that user request will goes to the thread and the user gets the response. Second thing, callback hell. Complex nesting of callbacks can lead hard to maintain code. And second thing, non-blocking IO model, input output model. But there comes some advantages also, like you can efficiently handle a high number of requests by employing the use of event queue and thread pool. But you can have you can have a limited number of thread pools. Like how much can you have 500 threads, or let's say workers, in the thread pool? Is it? No. The maximum numbers of thread or workers you can have is depend on the CPU, the CPU core. The max, let's say i i I have four workers or four threads. If my if I have total 8 CPU cores, then I can increase my workers to 8, and by default there are only 4 workers. Second thing, it consumes less memory and server resources. There's no need of multiple threads as event queue process one request at a time. The event First thing, the event will prioritize the execution. First it will prioritize the blocking operation, and after that it process the non-blocking operation. Let's implement this in VS Code. So I set up the TypeScript for a TypeScript project here. Let's import fs module from fs, and I also need a path module. Let's say what would be a file path. Const file path equal to my file.txt exists in the root directory of this project, so I will path.join process.cwd comma my file name, it's file.txt, and then let's do and there's two things, a read file and a read file synchronously. It's a blocking operation and it's a non-blocking operation. Non-blocking operation always returns its result in a callback. First parameter is file path, second parameter its encoding is UTF-8, and it returns first a result and second one is data. It returns a callback. Let's console.log async task completed. Let's now create const data equal to fs.read file synchronously, again file path and the encoding which is UTF-8. Then console.log synchronous task completed. Let's run this code. Npm run dev. See, first is synchronous task is completed, gets logged, and after that asynchronous task is completed, gets logged. Meant the blocking operation gets processed first in the call stack or the main thread, and after that the asynchronous task gets processed and gets completed and returns back to the client. Okay, so that's it for this video. We'll discuss HTTP servers in the next video, and we will see how to create an HTTP server in Node.js, and we'll make some endpoints there. We'll discuss some APIs there, and yeah, if you like this content, just hit a like button. If you learn something new with this Node.js architecture, hit a subscribe button. If you want these type of contents in this channel, just hit a subscribe button and turn your notifications on. Thank you. Signing off. We'll see you in the next video.